Hello, everybody. Welcome to this recombinant DNA technology course. Today's topic is polymerase chain reaction. Polymerase chain reaction, it is a common molecular biology technique which is developed by Carey Mullis in 1983, and for his discovery he has received the Nobel Prize for Chemistry in 1993. Is an efficient and rapid techniques, and with the help of this PCR we can amplify DNA or RNA sequences from various sources. PCR, also known as molecular photocopy. Actually, this PCR is a polymerase chain reaction. It is based on the ability of DNA polymerase enzyme to synthesize new strand of DNA complementary to the offered template strand. Actually, DNA polymerase they possess the ' to add new nucleotide, deoxyribonucleotide, at the pre-existing 3' hydroxyl end. Hence, we can say that DNA polymerase they needs a primer to which it can add the first nucleotide. And at the end of polymerase chain reaction, the specific sequence will be amplified in billions of copies. And these copies or PCR products, they are either known as amplifiers or amplicons. Once the DNA has been sufficiently amplified, the resulting product can be sequenced, analyzed by gel electrophoresis, or cloned into a plasmid for experimental purposes. So you can say that polymerase chain reaction, it is in vitro amplification of a desired DNA fragment. The principle of polymerase chain reaction is based upon three basic steps to each amplification cycle. These three basic steps are denaturation steps, annealing steps, and extension. If we talk about the procedure of polymerase chain reaction, actually nowadays it is carried out in a machine, automatic machine, which is uh, actually present in most of the labs, and this automatic machine, it is known as thermocycler or thermal cycler. So the procedure which is carried out by a polymerase chain reaction, it includes the first initial step, initiation of the PCR, in which the reaction mixture which has been prepared, they are kept for 10 to 15 minutes at high temperature. That initiating process is further followed by denaturation process, in which the DNA is whichever DNA which is actually present in the reaction mixture, PCR reaction mixture, it is denatured by heating to 90 to 95 degrees Celsius. So, when we talk about the different types, the different steps of PCR, uh, polymerase chain reaction, we must know about that what is actually what are the base of this polymerase chain reaction, or what are the components which are required for this polymerase chain reaction. So the components which are actually used for a simple PCR reaction consist of DNA template, the sample DNA that contains the target sequences, At the beginning of the reaction, high temperature is applied to the original double-stranded DNA molecule to separate the strand from each other. Then another important component is DNA polymerase, which is an enzyme that synthesizes new strands of DNA complementary to the target sequence. And the first thermotolerant or heat stable DNA polymerase, which has been used. It is named as Stark DNA polymerase, which obtained from Thermus aquaticus. And before the discovery of the Stark DNA polymerase, the normal DNA polymerase 1 has been used, and there are separate chamber in a thermocycler which requires the addition of this DNA polymerase 1 at the extension cycle after each and every PCR cycle. So that was very tedious job, but after invention of this thermostable DNA polymerase known as Stark DNA polymerase, the PCR process, it becomes very easy. So next component is primers. Primers are short pieces of single-stranded DNA that are complementary to the target sequence. The polymerase begins synthesizing new DNA from the ends of the primers. Then another more important component of PCR is DNTPs or deoxynucleotide triphosphates. The R4 deoxynucleotide triphosphate, which are actually building blocks for new DNA strands. Then another important component is buffer solution, which provides a suitable chemical environment for optimum activity and stability of the DNA polymerase. Then bivalent cations, typically magnesium or manganese ions. Generally, magnesium ion is used because it is a cofactor for DNA polymerase enzyme. So you can say that these are the PCR components, that is template DNA sample. These are the small oligonucleotide sequences which are used as primer. There are two types of primers, forward primer and reverse primers. Then all the four base deoxynucleotides and enzyme top DNA polymerase, the buffer, reaction buffer, and a PCR tube, which is also known as Eppendorf tubes or microcentrifuge tubes or PCR tubes. This PCR tube, it contains all these five components within this, and after adding an appropriate amount, this PCR tube, it will be kept in the PCR wells, and after placing this PCR tube into a appropriate position, the PCR cycle, it is allowed in a thermal cycler. And as I have told you that the basic principle of PCR, it depends upon the basic three steps, that is denaturation, annealing, and extension. In the denaturation process, which is carried out at high temperature about 95 degrees Celsius, which allows the separation of two strand of a double strand DNA template, and after separation of this two double strands, the primers are actually allowed to bind with the single stranded DNA of each strand of the double stranded DNA, and this happens because of the annealing by lowering the temperature from 95 degrees Celsius to around 60 to 40 degrees Celsius, which depends upon the melting temperature of these primers. So the melting temperature, the accurate calculation for melting temperature of the primer is a very important step in case of the polymerase chain reaction. After annealing temperature, which after annealing steps, which actually stay for around 1 minute. This 95 degrees Celsius denaturation step also for 1 minute, and then finally 72 degrees Celsius, which is an extension temperature for dark DNA polymerase. Because dark DNA polymerase, it shows its activity at optimal temperature 72 degrees Celsius, and this extension step is extension period is around 2 minutes, and after 2 minutes, then next cycle will be commence with the first step of denaturation. So 1 minute for denaturation, 1 minute for annealing, and 2 minutes for extension. Total 4 minutes is required for one cycle. It means it is required to double the number of DNA molecules or template DNA molecules or target DNA molecules, whichever are present in the starting of the polymerase chain reaction. So we are talking about the procedure of the polymerase chain reaction. You can see over here that this is a DNA sample, double stranded DNA sample, and we want to amplify this target sequence, and for this we have to go for first step of the polymerase chain reaction, that is denaturation. And denaturation can be carried out at 94 to 96 degrees Celsius for 1 minute, and it is required, it is necessary to separate these two strands from each other. After that, the annealing step has been followed. During the annealing step, the sample is cooled to 40 to 60 degrees Celsius, which allows the primer to attach the target DNA. And there are two types of primers, forward primers and reverse primers. So as we know that all the polymerase, they carry out the reaction, polymerization reaction in 5' to 3' direction. So 5' to 3' direction. This is the forward primer because it gives the cell's DNA, and this is the reverse primer, but it will produce the negative strand of the DNA. Then after extension, next cycle will be followed, and you can say the amplification of the nucleic acid or DNA, it is actually follows the exponential amplification, and after n cycle of after n cycle of polymerase chain reaction, you get 2 to the power n number of amplicons. So we will talk it later, but we first of all we must see this temperature profile for polymerase chain reaction as it is given here. This is the temperature in degrees centigrade, and this is the time period in second, that is per second. So we can see that from 1 minute to 30 seconds to 1 minute, there is a denaturation stage which occurs at 94 degrees Celsius. That is followed by abrupt cooling of or abrupt reduction of temperature up to 40 degree, or you can say it depends upon the TM value of the primer. That is, it can we say here it is about 58 degrees Celsius, and then abrupt change in temperature again takes place, which allows the elevation of temperature up to 72 degrees Celsius. So it stay for 2 minutes, and total time period from one cycle to second cycle, it will take about 280 seconds. So 280 seconds means 280 divided by 60. So then it will take about 4 minutes, 4 to 5 minutes.